Alright, this is Algebra 2 Lesson 69, Graphing Logarithmic Equations. So, we need to consider a few things before we start this. So in math we do graphing. Graphing gives us a picture of what the numbers are doing within a certain equation. Okay? And equations are usually, in math, they're called functions. And functions are like a math machine. You put ingredients into the math machine and then you get an output. For example, if I had a machine in front of me and I put sugar and flour and butter and some baking powder and some chocolate chips, what's going to come out of my machine if I put that set of ingredients in? What should come out? Cookies, right? I'm not going to get a taco and cookies. I'm just going to get cookies, right? Does that make sense? Right? Tacos sound pretty good right now. For breakfast, that sounds good. Okay, taco time. Anyways, so the same thing with math. If I put an ingredient in, I'm only going to get one output, okay? I'm not going to get two different outputs. And in math, there's one more concept we need to realize too. Everything has an inverse. It's kind of like the opposite, okay? So we starting from the basics. What's the inverse operation of adding? Subtracting. What's the inverse operation of subtracting? Good. What's the inverse operation of multiplying? Inverse operation of dividing? Inverse operation of squaring? Square rooting. Inverse operation of square rooting? Good. Inverse operation of exponential equations? Logarithmic equations. Good. Inverse equation or inverse of logarithmic equations? Exponential. What was that again? Inverse of logarithmic equations is? Okay, does that make sense? Everything has an opposite, okay? Or inverse. So we need that concept in the back of our heads, okay? And we're going to draw a graph with that today. So we kind of need the concept, and we're going to draw a picture of what the numbers do. So ingredients go in. Something pops up. Make sure your phones are off. Okay, whoever it was. Okay, whoever it is, turn it off. You're not getting in trouble. Just turn it off, please. So, these are the steps. So, we're going to be working with the inverse, and then we're going to be flipping back and forth, because we can't just graph a logarithmic equation simply. You have to know how to do it on the inverse. You graph the inverse first. Okay, so here we go. Numbers 1 and 2. They are kind of big and long, so watch right now, and then I'm going to give you a moment to talk and to write, and it's going to be plenty of time for that. So number 1, it says find the domain and range. I don't really want to worry about that today, though it's really important that you understand domain and range. Okay, so the first thing you want to do, I want to graph this log equation. So whenever I see a logarithmic equation, I need to first change it into an exponential equation so that I know how to graph it. So the way you do that first is you take your x's and y's, and actually I'll do it right underneath it. So instead of y, I'm going to put an x, and instead of a x, I'm going to put a y. Okay? I'm going to bring the rest of the equation down, common log of y minus 1 plus 3, and then there's that x on the other side. Okay? Any equation is always set equal to y, so right now y is not isolated. Alright? So we're going to isolate the y by solving for it. So we're going to subtract 3 on both sides. It's going to be x minus 3 is equal to common log of y minus 1 . Okay, then we're going to convert this into an exponential equation. It's going to be 10 to the x minus 3 is equal to common log, is equal to y minus 1. And we're going to add 1 to both sides, so it's going to be 10 to the x minus 3 is plus 1 is equal to y. And I'll set it all, so y is first. Y is equal to 10 to the x minus 3, all plus 1. Okay? Now at this point, you should be able to know how to graph an exponential equation from Algebra 1. Okay? Whenever you want to graph anything, we make an xy table. So I'm going to make an xy table. the x's are your ingredients or the inputs, the y's are the outputs, and I don't really have a clue for the first time of how this is going to turn out, so I'm going to start with just 0, okay? So 0, 1, 2, 3, 4, 5. These, I'll just start with small ingredients, see what happens. So let's put 0 in as an ingredient. 0 minus 3 is negative 3. 10 to the negative third is 1/1000th, right? 1/1000 plus 1 is 1 and 1/1000th. Okay, so I'm getting this really small fraction plus 1, right? Let's do 1. 1 minus 3 is negative 2. 10 to the negative 2 is 1/100th. 1/100th plus 1 is 1 and 100th. 2. 2 minus 3 is negative 1. 10 to the negative 1 is 1/10. 1/10 plus 1 is 1 and 1/10th. Okay. 3. 3 minus 3 is 0. 10 to the 0 is 1. 1 plus 1 is 2. Now I have a whole number. Let's put 4 in now. 4 minus 1 is 3. Or I'm sorry, 4 minus 3 is 1. 10 to the 1 is 10. 10 plus 1 is 11. 5. 5 minus 3 is 2. 10 to the second power is 100. 100 plus 1 is 101, okay, which is a big number. Now, this is the graph of the inverse, right, which is the exponential equation, but I need to graph the original problem, which is a logarithm, which is the inverse of this. So all you have to do at this point is copy the numbers into a new xy equation, but instead of copying the x's to the x's, we're going to flip them, okay? So all my x's, the 0 through 5, watch what I'm going to do. I'm going to put them in the y section. Okay? And instead of the y's, I'm going to put it into the x column. What am I doing here? Oh, 2, 11, and 101. Okay? So as you see how I copied them back now? Now I'm going to graph these, okay? So going to my graph, I'm going to go to 1 and 1/1000th, which is a really small fraction. So 1 and 1/1000th is just basically at 1. It's a little past it, and 0. We're going to plot a point there. Okay? Then we have 1 and 100th one. We're going to go put it up a little higher, or 1 point higher, but still very close to 1. And then we have 1 and 1/10th, 2. Okay, next one is 2, 3. The next one is 11, 4. So I'm going to have to go all the way to 11 up 4. Now, there is no 11, but I know my point's going to be way out here, it looks like. All right? I'm going to predict that. And looking here, there aren't any points going down, but what would have happened if I put negative 1 in? Well, this would have been 1 and 1/10,000th. Still would have been next to 1, but it would never cross. So I could predict that I would have points even down here, but they would never touch 1. So now I'm going to graph, which is just connecting my points. And graphing down, like so. Okay, so our base here is 6. So first step, to your neighbor, what should you do in your first step? You're doing this with me. This one is doing it together on your papers, okay? And then at the very end, maybe you could graph on your iPads, but I would suggest this is all on your papers because there's a lot of writing, right? You can't just do this all on your iPad. Okay, so we're going to flip the x and y, so I'll rewrite it over here so there's space. So we're going to write x equals log base 6 of y minus 1 plus 2. Okay? Now we have to solve for y because this is now a different equation, so we want to subtract 2 on both sides. Good, so it's going to be x minus 2 is equal to log base 6 of y minus 1. Okay, now that the logarithm is isolated, what should I do? Convert it to exponential equations. It's going to be 6 to the x minus 2 is y minus 1. Right? And then now we're going to add 1 to both sides, so it's going to be 6 to the x minus 2. All plus 1 is equal to y. So y is equal to 6 to the x minus 2 plus 1. Okay? Okay, that's not the hard part. Now we have to pick the numbers, right? We know that if I have negative exponents, I'm going to get fractions, right? Do you all agree with me?
Yes.
Okay, so we're going to pick some numbers here. I don't want to go too small because I don't want to get into too many negative fractional exponents because then, or not fractional exponents, too many fractions because then that's kind of redundant. So we're going to go x and y. Okay, y is equal to 6 to the x minus 2 plus 1. So I'm going to pick numbers that will not give me too many negatives. So I'm going to only go up down to 0 because 0 minus 2 is negative 2. 6 to the negative second is 136. So I'll go start with negative, I'm sorry, with 0. And we're going to put 1, 2, 3. That should be good. I'll do one more, 4. Okay. All right, plugging in 0. 0 minus 2 is negative 2. 6 to the negative second is 136th. Plus 1 is 1 and 136th. Boy. Okay, 1. 1 minus 2 is negative 1. 6 to the negative first is 1 sixth. 1 6 plus 1 is 1 and 1 sixth. 2. 2 minus 2 is 0. 6 to the 0 is?
1.
1. 1 plus 1 is? 2. Good. Good. 3. 3 minus 2 is 1. 6 to the first is 6 plus 1 is 7. So that's nice. I'm not dealing with fractions anymore. 4. 4 minus 2 is 2. 6 squared is 36 plus 1 is 37. So that's a really big number, right? That's not going to fit on my graph. Okay. So now I'm going to go graph, or I need to graph this, but I can't do it yet because this is an exponential equation right now. So now we have to flip it to do the logarithmic form. So it's going to be x and y are going to be flipped. Instead of writing all the x's again in the x column, we're going to write it into the y column. So we're going to put 0, 1, 2, 3, 4, and then copying the other numbers as the x's. Right? That's all we're doing. Because it's the inverse. All we're doing is flipping x's and y's. Now we graph. Okay, 1 and 136. Still a small fraction past 1. And it's at 0, so we're going to graph. I'll put a point representing that coordinate. Then we have 1 and 1/6, 1. Then we have 2, 2, 7, 3. Okay? And then we would have 37, 4, which is really far out there. But I know that if I had negative 1, I'd have 1 and, see, 36 times 6 is 16. 1 and 2 16s, which is just really, I could predict my points would be really here. But they would never cross 1. Okay, so I'm going to plot my points now, or graph them. And you can see this graph looks different than the first two with a base of 6. It actually has more of a curve here. Okay, it's not as dramatic. Okay, it's not as sharp of a turn. Okay, but that's how you do number 5. Okay, and that's it. All right. So the main ideas here, 2 main ideas. Inverse, the inverses of everything are really important in math. Inverse of a logarithm is exponential, or an exponent, and vice versa. So if you know those things, and you know that functions or graphs or representations of functions where we have an ingredient input in, we get an output. That's what the goal is of this. Okay. Tomorrow we're going to be working with graphs still, but we're going to be doing some exploratory activities with our calculators. Okay, which I'll have ready for tomorrow. All right, that concludes this lesson.